When and how to use distance versus displacement.
Displacement is how far something is from the start after it has traveled. Displacement is given by the integral of velocity. It is a vector quantity. Distance is a measurement of how much something has moved through space. This is the integral of the absolute value of velocity. Distance is a scalar quantity.
Use displacement when you want to know about an endpoint of travel over time, and use distance when you want to know how much something has traveled over time.
For example, you are asked to measure how far a frog has gotten after 2 seconds of hopping. The frog's velocity is given by the function v of t equals 1/2 cosine of 3t, where t is measured in seconds and the frog's travel is measured in feet.
This is a displacement question because you want to know about the frog's endpoint after 2 seconds, how far he is from where he started. Displacement equals the integral of velocity. The bounds are from 0 to 2 because we want to know the net change of the frog's position after 2 seconds. So, we use the integral 1/2 cosine of 3t from 0 to 2, which equals negative 0.0466.
The frog has gotten negative 0.0466 feet away from where he or she started after 2 seconds. Notice how the displacement value is negative. This means that the frog has traveled more in the negative direction than the positive direction.
Now you're asked to measure how far the frog has hopped during the 2 seconds. This is a distance problem because we want to know the total amount the frog has traveled.
Since distance equals the integral of the absolute value of velocity, and parts of the velocity function are negative, we must find the negative portion and make it positive, because that is what absolute value means.
In order to separate the positive and negative parts of the velocity function, we must find the zeros. The velocity function has zeros at 0.523 and 1.57 on the interval of 0 to 2.
The velocity is positive from 0 to 0.523 and from 1.57 to 2. Velocity is negative from 0.523 to 1.57 on the interval 0 to 2.
Therefore, the integral of the absolute value of velocity from 0 to 2 equals the integral of velocity from 0 to 0.523 plus negative 1 times the integral of velocity from 0.523 to 1.57 plus the integral of velocity from 1.57 to 2, which equals 0.62. The frog hopped for 0.62 feet in 2 seconds. Notice the graphs below. The second integral is multiplied by negative 1 so that the negative values in the velocity graph become positive. Naomi.
Will.
Ashley.
Thank you.